This video is about determining if a conjecture is true or false based on the given information, providing a counterexample to prove a conjecture false, identifying the hypothesis and conclusion of a statement, and rewrite a statement in conditional form. So first let's look at identifying patterns. So in the first one we have 0, 7, 14, 21. The pattern in this is plus 7 to every number. So the next number then would be 28. Number 2, we have 1, 4, 9, 16. So in this case, when I first look at them, I notice that they're not going up by the same number. So instead, I'm going to think of what's another pattern that they might use. And in this case, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So the next number squared would be 5 squared, which is 25. Number 3, we have January, March, May, July. So notice that the pattern is skipping a month. So the next month then would be September. Number 4, we have a smiley face with the face on the bottom, a smiley face with a smile on the left, a smile above, a smile to the right. So every time our face in the smile is rotating 90 degrees clockwise. So then we're going to go back to the beginning of our pattern for our 5th smiley. Now, what we have used here is inductive reasoning to make an educated guess. An educated guess is called a conjecture. However, not all conjectures are true. In order for a conjecture to be true, it must be true all the time. So there can never be an example that makes it false. To prove a conjecture false, we only need one counterexample. So complete each conjecture. In number 5, the product of an odd and an even number is, so think about multiplying an odd and an even number. So 2 times 7 is 14. 3 times 8 is 24. Every time we're going to be able to get an even number. Number 3, the product of two positive numbers. So think of any two numbers that you multiply, you're always going to get a positive number. Think about 3 times 2, 5 times 8, 10 times 11. All of those multiply out to a positive number. Number 7, the quotient of two negative numbers is. So when I take two numbers that are negative and I divide them, I'm always going to get a positive number. Because remember, two negative signs always make a positive number. Number 8, the number of segments formed by n collinear points. So if I have 1 point, I have 0 segments. If I have 2 points, I have 1 segment. If I have 3 points, I have 2 segments. So we notice that we always have 1 segment less than our number of points. So we're going to form n minus 1 segments, which means no matter how many dots we have, we're always going to have 1 less segment. In this case, we were given a conjecture, and now we have to determine if the conjecture is true or false. Remember, we only need one counterexample to prove a conjecture is false. So determine if the conjecture is true or false based on the given information. If it's false, give a counterexample. So in number 9, we are given A, B, and C lie on the same segment. So our conjecture is that A, B, and C are collinear. Well, the definition of collinear means that they're on the same line or segment. So this one has to be true because it's the definition. Number 10, given A, B, and C lie on the same segment, B is between A, C. This one is false. Just because they lie in the same segment doesn't mean all the letters go in the same order. So we might be able to change it and do B, A, C. So in this case, A was in the middle instead of B. Number 11, A is between C and R. So our conjecture is that CA is congruent to AR. This is also false. Just because it's between doesn't mean that it's necessarily in the middle. So we could have something where it's C, A, and then R is all the way over here. So we might have CA being 3 and AR being a length of 7. So that doesn't necessarily make it true just because A is between them. It doesn't say it's in the middle or is a midpoint, it just says somewhere between them, which fits our picture. Number 12, given a rectangle has an area of 36 units, the rectangle has sides of 3 and 12. Well, just because it has an area, remember that area is base times height. So this could be false because we could have other sides that also multiply to 36. So for example, if we have a rectangle with the sides of 9 and 4, the area would still be 36. Conditional statements. A conditional statement is written in the form P to Q, or if P, then Q. P is going to represent your hypothesis, and Q is going to always represent the conclusion. Notice that the words if and then are not included in the hypothesis and conclusion. They're just there to say, hey, look, here's my hypothesis, here's my conclusion, but they're not actually part of the hypothesis and conclusion. So read through the statements below, underline the hypothesis, and circle the conclusion. So number 13, if it is raining outside, then there will be no baseball game. So it is raining outside is our hypothesis. It's what comes after the word if. There will be no baseball game is our conclusion because it comes after the word then. Number 14, if you pass geometry, then you will take algebra 2 trig next year. So our hypothesis is you pass geometry, and our conclusion is you will take algebra 2 trig next year. Number 15, if the polygon has 6 sides, then it's a hexagon. So our hypothesis is the polygon has 6 sides. Our conclusion is it is a hexagon. So sometimes not all conditional statements are written in an if-then form. Sometimes we need to change the sentence in order to make it a conditional and write it in if-then format. So first we're going to change the statement into if and then we're going to underline the hypothesis and the conclusion. So number 16, a bicycle has 2 wheels. So we could say if it is a bicycle, then it has 2 wheels. So in this case, our hypothesis is that it's a bicycle, and our conclusion is that it has 2 wheels. Number 17, Warren students have school spirit. So we could say, if you are a Warren student, or if they are Warren students, then they have school spirit. So in this case, our hypothesis is they are Warren students. Our conclusion is they have school spirit. Number 18, 3 non-collinear points form a plane. So we could say, for our if-then statement, if there are 3 non-collinear points, then they form a plane. So in this case, our hypothesis is there are 3 non-collinear points, and our conclusion is that they form a plane. Number 19, a quadrilateral with 4 right angles and 4 equal sides is a square. So for our conclusion, or for our hypothesis, we could say if a quadrilateral has 4 right angles and 4 equal sides, then it is a square. So in this case, our hypothesis is a quadrilateral has 4 right angles and 4 equal sides. Our conclusion is it is a square. Number 20, get a free oil change with the purchase of a new car. Now, this is one that we have to be careful about when we go to write our if-then statement. So in this one, we go to write if-then statement. The thing that's happening is really the purchase of the car in order to get the free oil change. So we're going to flip this sentence around. And we could say that we're getting the oil change once we purchase the car. So if you get a free oil change, then you purchased a new car. So in this case then, our hypothesis is you get a free oil change, and our conclusion is purchased a new car. Another way to represent a conditional statement is the use of a Venn diagram. So the inner circle represents a hypothesis, and our bigger circle represents a conclusion. Because we could have many things that get us to the same conclusion, but the hypothesis is just one of those ideas. So for example, in this picture, our inner circle, the hypothesis is a golden lab, the conclusion is a dog. We might say, if your pet is a golden lab, then your pet is a dog. So we could have multiple other types of breeds to get us a dog, which is why dog is the conclusion. It's a bigger circle. So 21, we want to write an if-then statement given geometry inside the little circle and math class inside the big circle. So we could say, if you are in geometry, then you are in a math class. Number 22, our little circle is basketball and our big circle is athlete. So in this case, remember that basketball is going to be the hypotenuse or the hypothesis, and athlete's going to be the conclusion. So if you play basketball, then you are an athlete. So now let's try going the opposite direction. So in number 23, if you are in geometry, then you are taking a math class. So remember, whatever comes first is our hypothesis, and whatever comes second is our conclusion. So in this case, our hypothesis would be geometry, and our conclusion would be math class. Number 24, if you see a robin, then you saw a bird. So our hypothesis is you see a robin, our conclusion is then you saw a bird. So robin is our hypothesis, and bird is our conclusion. So remember that a conditional statement has a truth value where the statement can either be true or false. If it's false, when the hypothesis is true and the conclusion is false. To show a conditional is false, we only need to prove one counterexample. So 25, if today is Friday, then tomorrow is Saturday. That's true because that follows the calendar. 26, if an angle is obtuse, then its measure is 116 degrees. This is false because it's an obtuse angle. Remember, obtuse angles have a range of greater than 90 and less than 180. So we could also have an angle that could be 170 degrees. If a number is a rational number, then it's an integer. This is also false. Remember back to Algebra 1, rational numbers are numbers that can be written as fractions So we might have a number that's 2/3. So it is a rational number, but it's not an integer. So that's why it would be false. 28. A right triangle has only one right angle. So remember, we might need to put this into a conditional statement. So we could say, if it is a right triangle, then it has only one angle, one right angle. This statement's true because remember, we're going to learn that a triangle has 180 degrees. So if one of them is 90 degrees, we can't have another angle that's 90 degrees or bigger. So this is true. Number 26, a polygon with 5 sides is a pentagon. So if it is a polygon with 5 sides, then it is a pentagon. Of course, this statement is also true because all 5-sided figures are pentagons. That's the name for a 5-sided figure.